So let's take a look at some things we can do once we actually have a derivative. So in this example, we start with the function f of x is equal to x squared. If you go through that limit definition process, you can show that f prime of x is equal to 2x. And you have a few videos that show you how to go through that process, so I'm skipping it here to save a little time. What I've done is I've chosen 3 points on the original function f. So I've chosen the point 0, 0, the point 1, 1, and the point negative 2 and 4. If we take the x value from each of those points and plug it into f prime, we'll find the slope of the tangent line, or the slope of the function, or the instantaneous rate of change of the function at that point. So for instance, if we consider the point 0, 0, since x is 0, f prime of 0 is also going to be equal to 0. That is 2 times 0. So that's the value of the derivative, that's the slope of the tangent line, that's the instantaneous rate of change of the function x squared at the point 0, 0. If we consider the same idea at the point 1, 1, then since x is 1, we're going to plug in 1 to the derivative. We're going to find out that the slope there is 2. And if we go to our third point, f prime of negative 2, that's our x value at the point negative 2 and 4, we're going to find that the slope there is negative 4, interestingly enough. You can try this for other points. But I want to get across the point that we have a function, and we plug x into that function, and it gives us y values back, and that allows us to complete points. Then we have this derivative function. The derivative function also works off of whatever x is. So we plug x values from these points into the derivative function, and it gives us the value of the slope of the function, the instantaneous rate of change of the function, or the slope of a tangent line to the function at a point. And that's where we get these kind of numbers. Now we could also go a step further, and we could say, what is the equation of the tangent line at a specific point? So let's take the third example that we have here, the third point, negative 2, 4, f prime of negative 2 is equal to negative 4. In order to find the equation of a straight line, we need a point, and we need a slope. And that's exactly what we have. We know that this line is going to go through this point. It's going to be on both the tangent line and the function. That's a hallmark of tangent lines. And we know exactly what its slope is. So we'll use the point slope form. And in case you don't remember it, I'll write it down. Y minus y1 is equal to m times x minus x sub 1. And we'll plug in. So we'll have y minus 4 is equal to negative 4 times x minus a negative 2. That says that y minus 4 is equal to negative 4x. And since we're going to have a plus 2 inside here, we're going to end up with minus 8 when we take the negative 4 out front times the plus 2 we have inside. If we add 4 to both sides, we get y is equal to negative 4x minus 4. Now what you should do is you should take this original function, f of x is equal to x squared, and graph it. Use your calculator. Go into y1 and put in x squared and graph it. And then in y2, go in and graph this function, y is equal to negative 4x minus 4. And what you should find is that they should intersect at the point negative 2 and 4, that this tangent line will essentially just kind of kiss the function x squared right at negative 2 and 4. That is, it won't intersect it anywhere else right around that point negative 2 and 4. Matter of fact, in this specific case, it shouldn't intersect it anywhere else at all. And you should be able to see then that what we actually do create is a tangent line. This is a good idea to do with a lot of your work. Once you've gone through and done the calculus and done the algebra and all the analysis and you have an answer, don't be afraid to go back and use your calculator and take a look at the picture. Make sure you understand what the picture is telling you, how it relates to the work you just did, and use it to check your work. If you get a tangent line that is starting to cross through things, as comes through a function, maybe it looks like almost right angles, you know something's wrong. That can't be a tangent line. So please make good use of your graphing utility as you go through this course. It will really help you to understand the fundamental concepts of what we're doing, as well as allow you to check your work.